Okay, starting chapter 6, we are skipping the first two sections. Sorry about that. So our first section we're actually going to be in is 6.3. And we are going to spend 2 days here. Alright, we're going to do the derivative of the natural log function. So, the derivative of the natural log function, y equals natural log of x. Okay, on your blue sheet, I'm going to give you the rule. Let's write down here, it says the du, remember, is derivative of the natural log of u. This du does not belong here. I was thinking integral. That should not be there. But the derivative of the natural log function, it's very simple. It's 1 over the u, 1 over whatever this is, times the derivative of the u. So times u prime. So you could think of it as u prime over u, or I'd go 1 over u times u prime. Okay, today's what we're going to be doing is simplifying our answers with these log properties. So these two are getting combined today. It's the easier day of the two. Tomorrow we're going to do antiderivative. That's a little more challenging, always. So, just using that rule, just examples. So y prime would equal 1 over x times x prime. Okay, here we go. Start easy. Find derivative and simplify. Okay, first one. Y equals natural log of 2x. So we're doing derivative, so y prime. Here is my u. So it's 1 over 2x times by the derivative of just the u. The derivative of 2x is a 2. Put it over 1 since it's next to a fraction. Simplifying. 2's cancel. 1 over x. Number 2. Y equals natural log of 3x squared. So this whole thing is my u. Natural log of u. So the derivative would be 1 over u. So 1 over the 3x squared times by the derivative of just the u. The derivative here would be derivative rule. Multiply down, reduce by 1. So it would be 6x to the first. Now simplifying, 3 goes into itself once, into 6 twice, and I can cancel out 1x. So this one's completely gone. This one comes down to just x. So what we have left, if I multiply numerators, I've got 2 over x. Number 3. Y equals sine x times natural log of x. Okay, where do we start here? Hopefully by now you're picking up on the fact that I've got an x term times another x term. This tells me product rule. Okay, so I've got a u times a v. So following the product rule, starting derivative, so change the notation. I need the derivative of the u, which is cosine x, times by the v, plus, keep the u, times by the derivative of the v, so that would be, it's a natural log, so it's 1 over the u part of the natural log is the x. The derivative of x is 1. Just put it there just so I keep the pattern going. But that's it. As far as simplifying, there's not much simplifying other than to bring this together as one term. So cosine x, natural log of x, plus sine x, divided by x. Number 3, y equals natural log of 2x plus natural log of 4x squared plus natural log of x. Okay, remember your properties from yesterday. It's always best if you can simplify before you jump into derivative. You should always do that. And that's the case here, because I've got logs added together. And I know if I've got a log plus a log plus a log, it's the log of the product of them. So, this is not y prime. I'm not doing derivative yet. I'm just going to simplify what I've got. So I've got the log of 2x times 4x squared times x. I'm going to simplify this now that they're all together in parentheses, so this is still y. So this becomes 8x to the adding exponents, that'll be x to the 4th. Now I'm ready to do derivative. So y prime, the natural log of u, is 1 over u times by the derivative of the u. Derivative here, multiply down, that's 32, x cubed. Simplifying, 1, 4, all 3 of these are gone, 3 of these are gone, leaving me with 1, 4 over x. Okay. Oh, I did 2 3s. I'm like, why am I off on my numbering? It was a 4. Okay, now I know where I'm at. Example 5. Y equals natural log of 4x times natural log of 3x. Okay, can I simplify this first? Let me see if I've got a property that has a log times a log. No, I don't. I've got a log plus a log and a log minus a log. Don't get it confused with this one. So I cannot simplify anything here. So what rule am I going to follow to get this derivative? Hopefully, x term times another x term. That's product rule again. At the top of your blue sheet, if you still need that. I doubt you do. So jumping right into product rule, because I cannot do any simplifying to start. So y prime, derivative here is 1 over 4x times 4 times by the second one. And keep everything in fraction form so I know what my numerator and my denominator are. Plus, keep natural log of 4x times by derivative here. That's going to be 1 over 3x. So I'll put a 1 under here. Times by the derivative of this, which is a 3. So now simplifying, 4's cancel here. I get natural log of 3x all over x plus 3's cancel here. Natural log of 4x all over x. Can I simplify this? Yes, it's 2 fractions with a common denominator. Just like if I had 5/8 plus 1/8, we would add numerators and keep that common denominator and get 6/8. So here, I'm going to keep the common denominator of x and add my numerator, so I get natural log of 3x plus natural log of 4x. Can I do anything with that? Is there a property that lets me combine 2 logs if they're added together? Well, log plus a log goes to the log of a product. Yes, I can. You should always be looking back until you get real familiar with these, so you don't have to look back. So this becomes, I can combine these and make it the natural log of 3x times 4x. If you want to do that in one step, go ahead. Which becomes natural log of 12x squared when I multiply all over x. Do not cancel here. These are not like terms. This is inside of a log, so I can't just take away part of it. And that's as far as that goes. Let's see. So, switch notation. R of x instead of a y equals natural log of 5x divided by natural log of x. Can I simplify that before I start? A log divided by a log? No. The only time I have two logs is when I've got an add between them and a subtract. That's the only time I can simplify something. So, I'm ready for what rule here? Think about it, an x divided by an x. You're going to follow quotient rule. So I'm ready for derivative, r prime of x. Quotient rule says take the derivative of your numerator, which is going to be a natural log derivative, which is 1 over 5x, times by 5, times the bottom. Just keep everything lined up when you've got these fractions going on. So that was my u times my v prime, minus, keep the top, natural log of 5x, times by the derivative here, the natural log, so it's 1 over x, times by the derivative of x is 1. Then that's all over bottom squared. Okay, simplifying here on the top. 5's are gone. I have natural log of x over x. Minus natural log of 5x over x all over natural log of x squared. Okay, that 2 does not come in on the x. That doesn't work here. In the top, though, I have a common denominator, so I can bring the numerators together. So I get natural log of x minus natural log of 5x all over x all over natural log of x squared. Okay, because I've got this fraction up here, I'm going to make the bottom a fraction by putting it over 1. I'm going to do a couple things here because I'm running out of paper. I'm going to combine these together, and I'm going to flip this bottom one over and multiply it by this top fraction. So combining here, because I have a property, a log minus a log, I can bring that together as the log of a quotient. So this is going to become the log of x divided by 5x. Then that's all over this x. Now I'm going to multiply by the reciprocal of this bottom fraction here. So flipping this over, that's 1 over natural log of x squared. I'm going to move vertically now. Simplifying here, the x's will cancel. That leaves a 1 in its place. So I've got the natural log, and multiplying here, I've got the natural log of 1/5 divided by the natural log of x, that thing squared. And I have no property that lets me simplify a log divided by a log. Only a log minus a log and a log plus a log simplify. Okay. Number 7. We've got y equals the cosine of the natural log of 2x. Okay, what's going on here? What rule are you going to follow for derivative? Well, I only see one x term in here, so this is not a product rule. This x term is actually in the angle of cosine. So this is just a cosine derivative that I'm following. So it's cosine deriv. So I'm ready for derivative. Derivative of cosine is negative sine. I never ever change the angle. This is like my u, cosine of u. But now I've